what we are telling you right now is this small thing that's, again, it's very niche, very specific today, but maybe again in a year or something, you will find that it's both helps your careers and your projects that you do to basically be more successful and to deliver them faster and better.
So the name of this workshop is Unlock the Blockchain's Potential, and welcome Yolos, and how to build your own. We have a very ambitious agenda today. We'll see what are we going to get to cover. So first things first, who am I? My name is Ailyos Shamakiv, and there's an echo, okay. But you can call me Aki if that name has some weird letters that you're not used to, which there probably are. And I'm the Development Excellence and Education Manager at Gateway, which is just a fancy way to say that I like learning and I like sharing knowledge. I'm also a member of ETH Belgrade, which is a Web3 event organization. And we organize Belgrade Blockchain Week, basically, hackathons, side events, conferences, stuff like that. I'm also the project manager of another conference that's tech agnostic, so we cover like a bunch of different things. But at my core, I'm a programmer and I have a bachelor in science in web development. All right. I'll tell you later why I asked. My hunch was pretty correct. So to get to Web3, it's important to go through Web 1 and Web 2. Like, don't worry, this won't be like a full-on history class. I just think the context is important. So uh, the start of everything was in 1991 when Tim Berners-Lee launched the World Wide Web. And that was crazy revolutionary because for the first time you could access some data wherever you were if you still had like a computer with you because smartphones still were not a thing. But you could only read that data. You couldn't manipulate it in any way. There was no styling. It looked like the old Wikipedia, but it was cool because for the first time you had something that linked to something else that wasn't on your actual like hard drive. So a little bit later, when our hardware and software evolved, we moved on to the read and write era, Web 2. And we're in this era right now, kind of mixed with Web 3. But what's a staple of this era is user-generated content everywhere. So we have like the birth of a lot of major platforms whose main like business model and concept is for you as the user to add your data and generate content for the platform itself. Also, smartphones become a thing, which only expedites like the evolution of the internet. Web design explodes, and we have like Instagram, Facebook, and everything else. And with that, we have the birth of some major titans, such as Apple, Meta, Google, Amazon, Netflix, and others. And they start amassing huge amounts of users. And with huge amounts of users comes a huge amount of data. And with that data, they started having a lot of power that they started misusing because there was still no regulation. And even if there was regulation, oftentimes it's cheaper for them to pay the fine instead of trying to find a different, slower way to do with the data whatever they wanted to. And that starts raising huge issues like in the tech industry and globally in general, because, for example, 95% of all app downloads go through Apple's App Store and the Android Play Store. Like 97% of all searches online go through Google. And when they have these monopolies, they can set the rules, they can set the fees, and they can do anything they want, and that stifles innovation. And this isn't like some old man conservative speech. We have proof over and over again that they misuse the power they have. So, for example, you probably know about like Facebook's Cambridge Analytica data scandal. Facebook sold a huge amount of data to Cambridge Analytica that was involved in creating campaigns in the UK during the whole Brexit situation. And they definitely used that sensitive data of users uh, to persuade people to one side or the other because they knew specifically how to target them and what would evoke specific emotions in them. Uber has made their own internal like Greyball app, which is an app that helps their drivers avoid the police and any like legal authority while their cars are driving. They even built a God view mode, which tracks users' location even when the user is not like in an active ride and the user has no idea about it. Even like when a huge entity like Yahoo doesn't misuse their data, it often gets breached. So in 2013 and 2014, Yahoo got breached twice, and the data of over 3 billion accounts got leaked online. And every year, at least some social media is hacked as well. And sometimes it's not even from the technical side, just some people get bribed more than they're paid for a month, and they just get the data or do whatever they were paid to do. So there are a bunch of issues happening all around with the current system. So the main idea of Web3, let's say the wave started around 2008 and after, is read, write, and own. And the main point of Web3 is for users to be in control of their data and to own their data. And that way, monopolies don't have the power to do with your data whatever they want. The main point is to decentralize that power, and it's all about making things that are open source and that are trustless in the sense that they can be verified transparently by anyone, so misuse doesn't happen. And this maybe sounds like a revolution compared to like what we have currently, or something that's kind of like punk, but this is actually what the internet was initially supposed to be, decentralized, trustless, and open source. Because if you look at quotes from Tim Berners-Lee that actually started the World Wide Web, from the start, he talked about how important it is for anyone and everyone to have access to the internet, uh, to have freedom of speech on there, and for the evolution of the internet to be led by everyone. It should be a group discussion, and it shouldn't be decided by like a small group of people behind closed doors, like is happening now in Silicon Valley and everything. So I asked you this, what do you think about when you hear the word blockchain? Because something I get a lot as someone who is in Web3, from people that are not in the industry, I get like, oh, so in Web3, what crypto should I buy? Because usually the perception is that the Web3 industry is cryptocurrency and blockchain is cryptocurrency, and that it's kind of like the same thing. But my first point of today is that cryptocurrency is an important and vital part of a blockchain and Web3, but there's so much more to it, like the values that I just spoke of, and we'll talk about utility throughout the whole day. So the first blockchain that kind of made a splash is definitely Bitcoin. And the whole value proposition of Bitcoin, it was and is free flow of value. And we'll get into what that means. but I just wanted to cover that it was launched in January 2009 by Satoshi Nakamoto. And the interesting thing about this is that nobody actually knows who Satoshi Nakamoto is. It's most likely a pseudonym, and we don't know if it's a guy, if it's a girl, if it's a team, if it was one person. There are forums that you can track when the person or the team was posting about launching Bitcoin. And at one point, we lose all trace, and still to this day, we have no idea who's behind Bitcoin. So the first question is, when was Bitcoin launched? To see if you're paying attention. So is it January 2008, January 2009, or February 2008, or February 2009?
There I can see it.
All right. So 4 got it right, and then 7 got it wrong. All right, cool. So as I said, Bitcoin introduced the free flow of value, and that introduces us to the question, like, what is actually the difference between currency and cryptocurrency? And regular currency is also called fiat, and crypto is called crypto. So sometimes I might say fiat, that just means I'm talking about euros, dollars, etc. So what's cool about cryptocurrency, specifically like Bitcoin and Ethereum, is that there are specific rules and mathematic equations like integrated into the blockchain network. And through that, Bitcoins and Ethereum ethers are being printed. And the difference is, like in any country, a president can say, let's print like 1 million more dollars because we need it. And they just do it. And then that makes inflation. It decreases the value of all the money that's in circulation. But with crypto, there's no way to do that except to wait it out and uh, abide by the rules of the protocol. So that's great and that's very healthy. Does anyone have access to it? So any currency that's connected to a country is available within that country. And outside of that country, you're gonna have a hard time using that currency to swap something valuable for that. But Bitcoin you can use anywhere. So it's the first actually global currency that we have. So as I said, yeah, it can be used anywhere and anybody has access to it. You don't need to go through any like KYC. KYC is know your customer, where like a bank will go through and do a background check on you. They will get your info, find out, well, like what's your identity. But for Bitcoin or Ethereum, you just don't have to. Anybody can make a wallet and you can get some Bitcoin. Well, you used to. Getting Bitcoin now is a little bit harder when it's $100,000, but you do have access. And you can send it to anyone, anywhere in the world if you just have their wallet address, just like sending an email. There are no like borders and restrictions stopping you from sending money. Because like if I wanted to send some of you some money through my current bank account, that would initially be flagged. Like, why are you sending money to Abu Dhabi all of a sudden? Or why is someone from Abu Dhabi sending money to Serbia all of a sudden? Because I'm in Serbia currently. Then we would have to wait some time. They would probably contact us. Then we sort out the papers, and then they would probably let it go through. But for some countries, they'll definitely stop it. But for crypto, there's no way of stopping. You just send it from one address to another. So let's go through how the blockchain actually works. It might seem complicated, but I've divided it into 3 basic components. And if you get these components, you understand how the blockchain works. So first things first, you have a distributed network of computers with a shared ledger. I'll explain. You have private key cryptography. I'll explain that as well. A bunch of fancy words, but it's simple. And you have to have an incentive for the members of the network for everything to be sustainable. So first things first, for this to actually work, we have to have a distributed, decentralized network of computers that hold up the whole blockchain network. Or specifically, let's talk about the Bitcoin network. Because if it was centralized, if there was one entity providing the infrastructure, like Google provides the infrastructure for search or whatever, then there would be a single point of failure. And you could switch off that computer and the whole network would be down. But this way, if you have as many computers as you can to put down the network, you would have to put down all of these computers. So that's why it has to be decentralized. That's why there can never be like an admin that's behind the scenes in control. In one sense, no one's in control, but in one sense, everybody's in control because everybody keeps each other accountable. Okay, why is cryptography always like connected to the blockchain, and why are they like talked about together? So now we're going to cover like why a blockchain is called a blockchain or a chain of blocks. What actually connects these blocks to one another? Usually when I'm on site, when I'm holding a workshop, I would go through the room and I would give everybody two pieces of die or dice. So imagine one of you is like this block, the person next to that person is this block, the person next to that person is this block. And imagine that everybody has two pieces of dice. So if you picked like any random number for this first block, that's called the Genesis block, the first ever block of a blockchain. If you had two pieces of dice, and let's say the numbers were like 4 and 6, the next block to be connected to the previous block, it's gonna have a part of the information of the previous one just to like click as Legos, but mathematically. So if this first block has number 4 and number 6, this second block is gonna have number 4 as well, just to be able to link it back to the previous one. And it's gonna have its own like block data for some of its own transactions. And that can be number 3. So here we have 6 and 4. This has 4 and 3. That means the next block, it's gonna have number 3, and you can have whatever value will represent like transactions in that block. It can be 5. So the next block after, it's gonna have the 5. So it's linked together. And then it's gonna have its own number. It can be 1. So the next one, it's gonna have 1, and it's gonna have another number, and so the streak continues. So basically, a cryptographic hash, like a short string that's unique and made from the content of that block. So you know that hash only belongs to that block, and you take that hash, and the next block contains it within itself. And that's what links it, so you know this block comes right after this block, and this block comes right after this block. And you have an actual chain of data. And this is very cool because when you have this whole network and you have a bunch of blocks stacked up and you want to add the next block, all of these computers, as I said, they have a shared ledger. So everybody has the copy of all the same transactions. It's like one database copied 1,000 times for 1,000 computers. So anybody can check if the information is correct. So you want to add a new block. And if a malicious computer tried to go back in time and say, no, a week ago in this block, Alyosha actually sent 1 million Bitcoin to this other address. It's not going to work, partly because every other computer already has a copy of the correct database, and they're going to say, no, Alyosha never had 1 million Bitcoin. There's no way he did that. And then that computer that tried to be malicious is going to get flagged and removed from the network. Another cool thing is, so if I wanted to change like this block, the first one that's red, even if I did change it, like imagine the numbers were 4 and 6, and I changed the 6 to be a 2, that would mean in the next block, I would need to change the 6 to a 2 because it has like its data and it needs to link up for the chain to be correct. So the malicious computer would have to like go and change all the blocks from that one to the end. By end, I mean like to the latest block. And blocks are being added actively. So you're kind of in like a never-ending race to manipulate even more and more blocks. So it's computationally very hard. You would have to have like a supercomputer, and you would have to have like all the other computers on your side. So he's removed, and everything's okay again. And the third part of the whole equation is like, what's the incentive? Why would all these computers be a part of the network and give their own like processing power and electricity? Well, because for doing their job, they get tokens. In the Bitcoin network, they get a certain amount of Bitcoin. As time goes on, all the miners, they're called miners, will get less and less Bitcoin. And that's part of that equation that I mentioned. So now I'm asking you, how clear is this? And you tell me if it's not. I realize I said like a bunch of new stuff right now. So like give me a yay or a nay in the chat. Even if everybody understands, and if you don't, it's totally okay. I'll cover whatever part is not clear. So who launched Bitcoin? Satoshi Nakamoto. Satoshi Nakamoto, nice. Satoshi, I accepted that one as well. Lee, you can think it with Tim Berners-Lee that started the World Wide Web. That's a common mistake when I make these slides. Satoshi Nakamoto, just because of a typo. And Satoshi Makato. That sounds like sushi. All right. What links one block to the previous one? Hell yeah. All right. I'm very happy. Did you guys know something about cryptographic hashes right now? Who controls the network? Is it one supercomputer? Is it a select few members of the network? Is it that everybody's equal, or is it the computers with stronger hardware control the network? All right, cool. I'm glad most of you get it. So the whole point is that there are no admins, just like there are like in a Twitter database or a Facebook database. Everybody has access to the same copy of the same database. Everybody has equal rights, and it's about keeping each other accountable. So the system is definitely trustless. Okay, so some time passes. Bitcoin matures a little bit, and people realize the potential of the technology. And obviously, people start building different blockchains because now they have different ideas of how it should work and what should be best. And I'm going to get into some other blockchains a little bit later, but the main one that I want to talk about is Ethereum, because they implemented one important innovation that the Bitcoin network hasn't. And that's besides having the free flow of value and everything we just talked about. On Ethereum, you also have the power to build anything you'd like on top of that network. And we'll talk about that. So Ethereum was launched in July of 2015 by Vitalik Buterin, this fun guy right here. This is kind of like the timeline. So I just wanted to show you that like basically every year, most years, all networks, but especially the Ethereum networks goes through a specific upgrade or change. So the way a blockchain is initially built, it doesn't stay that way forever, but there's a decentralized organization that that kind of governs that, and people vote. So it's still not like one team of people, the whole community is involved. 2016 was interesting because that year is the year a major exploit happened, and Ethereum got forked into two separate chains, and they keep on living in parallel now because neither of the two like sides could agree whether they should move on, like the funds were never stolen, and a lot of funds were stolen, or if they should move on, like the funds were stolen and not rewrite anything in the chain. The chain was shut down temporarily. So they launched a copy of the chain, one chain with the funds intact, and one chain like it never happened, and one chain uh, with the funds stolen, because if everything is unchangeable like it is, then that mistake should be there as well. And 2022 was interesting because that's the year that Ethereum switched from proof of work to proof of stake, which is a consensus mechanism, which is a fancy way to say that's how blockchains make decisions on what block is true, what transaction is true or not. So the Bitcoin has proof of work, which I actually talked about, and those are like each member of the network goes through like some complicated equations, trying to get to the right answer as quickly as possible, so they can be the one that adds the next block to the chain, as I showed you. But the problem with that is that it requires a ton of electricity and resources. It's very heavy, like for the planet. And people with like better hardware tend to win. So because it was unfair on multiple levels, and Ethereum worked like that as well, they switched to proof of stake. So you have specific members of the networks who stake, basically invest a lot of their own Ethereum, and then they do what they would usually do, just like on Bitcoin. They find malicious actors, they add blocks to the chain, and then after a certain amount of years, they will get those funds back. But if they're being malicious, they will lose a part or all of their funds. So basically, it's like put your money where your mouth is if you're going to be a validator, and a validator is the one who like says, yeah, this transaction is correct, this one isn't. So as you can see, like Ethereum is exponentially faster than the Bitcoin network. It adds a block to the chain in 12 seconds on average, and the Bitcoin does that in 10 seconds. But the major thing is that it allows you to build on top of it. And what I mean by that is Ethereum has smart contracts. So on any blockchain, you can upload any data to be in that block, the next block you're saving. It can be text, it can be image, it can be whatever. But Ethereum implemented this so you can actually upload executable code to the chain. And then you can trigger that code while it's on chain. So all of a sudden, you can build your own custom logic and you can do whatever you want, just like you would build your own app. And on Bitcoin, you can't do that. You can just upload like static data. So that means in a situation where I want to like exchange with some of you, I want to exchange 50 euros for $50. Up until now, someone would have to trust the other person first. So I would either have to send you 50 euros first and then you send me $50 back, or you would send me $50 first and then I send you 50 euros. But in that in between state, there's a chance you're not going to send me the money, but I have to trust you and wait. We can write our own smart contract and we can write the logic so I can send the money to the smart contract. You send your money to the smart contract. And then once all the conditions are met, I sent my 50, you send your 50, then it sends your 50 to me and my 50 to you. And it does that automatically. And all the smart contract code is transparent, just like any other transaction is on chain. So anybody can read that code and see, oh yeah, this is actually what's going to happen. And nobody can manipulate it because there's this whole set of rules stopping anybody from changing any information that's already been saved. So if you wanted, you could technically write a smart contract to hand over the deed of your house if certain conditions were met, if a specific amount of money was deposited in that smart contract, maybe in a specific time frame. It can be like whatever you want. You've definitely heard of tokens, like and there being multiple tokens on one specific blockchain. And the token is actually nothing more than a smart contract. We have like a standardized set of rules. A token should have this function, a token should have a name, one token should be dividable by this many parts. And if it abides by those rules, that is a token. We can just write that code and it's basically like 7 lines of code. It's super simple. So NFTs, I'm sure you've heard of them. They're also nothing more than a smart contract. It's just a piece of code that has those specific like capabilities that an NFT should have, in the sense that like it's tradable, it's not tradable. There's one version of it, there's 5 copies, and it's all transparent and you can see it. So any dApp is nothing more than a smart contract. It's not a dApp is a smart contract and there's some front end there. There can also be some back end. It doesn't have to be 100% on chain, the data it's reading, but it has to interact with the blockchain somehow to be a dApp. And when I say dApp, I mean decentralized app. The D is just for decentralized. And you'll see like there's a D for decentralized in almost anything. DeFi protocol, as in decentralized finance protocols. They're also nothing more than a few smart contracts working in some specific rules and allowing you to swap one type of token for another type of token based on their like relative value. DAO governance. DAO means decentralized autonomous organization. Just a fancy way to say there's like a decentralized committee working on deciding the future or the rules of something. Usually like all the decentralized exchanges and important protocols, they have DAOs because it would be too dangerous and against the whole point if we still had like one centralized admin that will be governing whatever the thing is. So you just write a smart contract with custom logic. This is how you make rules. This is how many votes you need to make this decision. This is who has votes. One token is worth this many votes, and you're good. And you can make any custom logic you want. just like any automated royalties for like an NFT or a song you make every time it's sold. Like by default, you can have a percentage that's coming to your wallet the whole time. And you don't need any like special third-party service or entity or bank to help you with that. It's all like without middlemen now. So when someone asks what does the blockchain offer us, like as a technology, so many things. So now you realize decentralization is a key component. Transparency is a key component because any transaction, any smart contract code, anybody can look up any single thing or wallet. You own your wallet and no one can take that away from you. And you own those tokens. If you write the smart contract in a way that you own it, that's it. There's no like back access unless you wrote it in. It's a trustless system because you have this set of rules that everybody has to abide by. You don't have to take my word that the 50 euros will be deposited into your account. You can see whether I actually sent them in the smart contracts. Increased efficiency and speed because you don't have to go through a bank or a middleman and get their approval and go through some processes. It's all automated without humans. Traceability, in the sense that like you can find my wallet and you can see any transaction I ever made. Or you can see like you can find an NFT, which is like a unique digital asset, and you can see like every person that ever owned it in the past. Automation I spoke about, and like on top of all of that, you have like a built-in way to transfer value, and you have cryptocurrency for that. So when someone says like the blockchain is the same as cryptocurrency, now you get what I mean. Like cryptocurrency is super important and it wouldn't work without it. But like the whole picture is so much larger than that.
Is the token is actually like a smart contract, or I mean like, or a smart contract is something that manages the token, the token. I mean like the token is a product and the smart contract is kind of like a machine that creates and manages it.
Well, the token is nothing more than a piece of code, and the smart contract is just a name for that like code that makes it what it is, in the sense that Ether is called Ether and its ticker is ETH and it's divisible like by 18 zeros, stuff like that. Within it, you can have custom logic where like the organization running it or the team, they can manage certain funds at certain points. So it can be used to like manage it as well. But it definitely the token is the smart contract,
Okay, thank you.
if you get what I mean. I mean, later we'll be like coding some basic smart contracts, and I think then it will click. I get it's kind of abstract right now. Sure. Any other questions?
Yeah, I have a question.
Sure.
So currently, in Web2, big companies are actually benefiting from it with like getting our data for advertising purposes or even selling it. Some others have like subscription models. In Web3, what makes big companies interested in, and how can a company like get benefits from it?
You mean in Web3, like if it doesn't profit from data, then how does it profit?
What do you think, or give us examples why companies can actually start get interested in blockchain, like what they can benefit from, like big players.
Right. Well, there are a lot of benefits. I can tell you, like, for example, a big one is in the supply chain industry. When I say supply chain industry, I mean basically like imagine Walmart in the US and imagine like the amount of like storage they need to have and how many moving parts for them to get like I don't know, as many cupcakes as they need to every store, as many like hammers, computers, uh, some some basic like materials so they can like build some stuff in the store. And then imagine like hundreds of stores working in parallel. And then imagine the system that's used to track all the shipments. Imagine what happens when it's late, when you lose a shipment. It's just crazy to keep track. And there are like millions and millions of dollars being lost all the time in somewhere in the supply chain. And the blockchain is actually perfect for that because first of all, it's transparent, so you can track everything in real time. You can know in real time where anything is, what's happening. The second thing is because it has like a standardized way of working, the blockchain and the smart contracts. If everybody used that system, it would be so much easier to combine everybody's data because it will be stored in the same way. So then a company that uses the blockchain to have like a simpler, more standardized, efficient way of tracking everything that's going on like in the supply chain, um, they're gonna be losing a lot less of their stuff and losing a lot less of their money. I can give you some other ones, but maybe when we go through them through the slides, um, you'll get a few more aha moments. But we can talk about examples more later for sure. Okay, so some basic terms that we need to grasp before moving on. Definitely the wallet, because your wallet is basically your account in Web3. And you use it to store your crypto, you use it to trade, you use it to buy anything. On that wallet, you can have NFTs, which are digital collectibles. And without it, you don't have a way to interact with anything on chain. So there are two main components of every wallet. There's the public key and there's the private key. The public key is basically like your home address. Like I live in this street, that number, that floor. It's unique to you, and that way somebody can find you. This is the same thing, but digital. It looks kind of ugly right now. I'll show you. So on Ethereum, I can like open a page. I don't know if you can see. On Ethereum, each wallet address, it starts with like a 0x, and then it has like a bunch of these letters, numbers, and stuff. This is a hash, basically. So this is my public key. And if anybody wants to send me money, if they like type in this address and like the amount of whatever, I'm just gonna get it, whatever I am in the world. And it's not linked to my identity. So like now you know that I have control over this address, but there's nothing, if I didn't tell you, if you just saw it in the wild, it's just an address like any other. So that's important, and it's okay if someone sees your public address. It's not okay if someone sees your private address or your private key. Uh, so each public address is unique. There are no two of the same kind on one chain. And the same goes for the private key. So each private key is unique and it's linked to a specific address. So it's unchangeable. It's usually a mnemonic, and that's a fancy way to say that it's a combination of 12 words. The order of the words is very important, and you should never ever let anyone see your private address, because as soon as they have it, they have control over your wallet, and it's over, because you can't change the password itself, or as some of you said, someone lost their private key, and then you lose access forever as well. So that's another difference between Web3 and Web2. There's definitely a greater amount of responsibility, because if I lose my email password, I can just say reset password. I'm going to get another email. I'm going to change it to like 1243 instead of 1234, and I'm going to feel safe. But that doesn't exist here. So you use that key to sign transactions. And because only you have that key, it's your unique digital signature, and that's what gives you access to that address, that wallet. And what's also different is that, like, I can make an account on Instagram and I can get blocked, or my account can get deleted and I lose all of my data there because it was never mine to begin with, right? But it's different in Web3 because I have my account that exists independently of any app. It exists on the whole network. So if a Web3 app shuts down, or if I'm like blacklisted or blocked or deleted, I can't actually be deleted. They can stop me from using this app, but all my data and I'm still here because it was never theirs. I'm still the owner of everything. So I can just go to this other app. I don't care. So the user has a lot more power. So what is a transaction? A transaction is just a request that you make to the blockchain network to do something, whether it's like swap some money, change a value of something, like variable I equals 4, and if there's a function to change it, you can change it to variable I equals 2. That's a transaction. Deploying a smart contract on chain, that's a transaction. So anything you do is a transaction, and each member of the network has each transaction noted down, and then they compare these copies. Yeah, so this is just the life cycle of a transaction. As I said, Alice wants to send some money to Bob. She needs to like say, okay, I want to send money to Bob. It's going to be 2 ETH, and I'm going to sign this transaction. And then that transaction gets turned into a hash, and it goes into a pool. And then miners, which are the validators that I spoke of, they just pick the order of the transactions. They're going to add to the chain of blocks. And then when the block is added, Bob sees, oh, I got 2 ETH from Alice. And that's pretty much it. Now, one part I left out on purpose, and that's gas. So every time you execute a transaction on chain, you have to pay a gas fee. And that goes back to everything we talked about in the beginning when I said like the whole network is decentralized. There's no one admin of it. That also means there's no one person like paying the bills. Like Google is paying for their own hosting costs, but we as the members of the network, we need to split the bill because we're all holding the network up. We're all keeping it up. So for every transaction, you have to pay a gas fee, similar to how you probably pay a fee every time you have a transaction like through your bank account. So we spoke about gas, how if you want to change any state on chain, change any data, you need to pay gas. Simplified, it looks like you paying the blockchain and then the blockchain passing those fees to the members of the network that are actually making everything work. So that way it's a sustainable system. The token you already know about. It's just a term for 1 unit of a cryptocurrency. As I said, it's nothing more than a smart contract. Anyone can make a token on any blockchain, but that doesn't mean that it's worth something. Whether it will be actually worth something or not is really like more of an economic question than a technical question, because it needs to have utility. There has to be a reason for people to use it. If people use it, it will have value, and then it snowballs from there. I can make a Alyosha token today, and it won't be worth anything just because it exists. As I said, like we use agreed upon standards to unanimously agree what is a token and what isn't a token. And that literally looks like this. This is like Solidity code, and this is like, okay. So in order for a token to be a token, it has to literally have a name, a symbol, a specific amount of decimals. It has to have a total supply. You can't have, I mean, you can infinitely make more if that's your tokenomic logic, but it just needs to be defined. And balance of, transfer from, those are just functions that you use that every token has to check if a specific address has any of those tokens. So it's pretty simple. Ethereum's native currency, every blockchain has a native currency. Ethereum's is Ether. And it consists of Wei. Wei is like the most atomic unit of ETH, and 1 times 10 to the power of 18. Wei is 1 Ether. So you can divide it up a lot more easily than a regular currency. And of course, there are a bunch of other different tokens. I would just like to mention USDC. That's interesting because it's a stable coin, and a stable coin has a persistent value of $1. It's linked to $1 through some math that I do not understand, but it is linked to one consistent value. Unlike Ethereum or Bitcoin, which are very volatile. But I just wanted you to know that there are tokens that have a consistent value. They're backed by something else, usually fiat money. There are other ways, but yeah. Block explorers are important because those are actually the platforms where you can see any transaction or wallet balance or whatever. So each chain has their own. Etherscan.io is the block explorer of Ethereum. And there you can see what's the current price of Ethereum, the number of transactions ever been made, are being made within like a second, last finalized block number, and I can see like literally any transaction. So this transaction happened like 12 seconds ago. I can see its own unique hash, which is kind of like the public address of a wallet. Also, transactions have that, but that's unique. I can see, okay, so this amount of ETH was transferred to this address, and that cost this much gas fee. So they paid $2 to transfer $93 somewhere else, and I can see other details and stuff like that. So every chain needs that. So you can't change the value of your wallet's private key. You are correct. So it's not like changing a password. After every transaction, you have to pay what? Damn, I'm sorry. Whoever said gas fees, that should have counted. I didn't anticipate someone would put a plural. I know for next time. Let's see the points. Looks like LoveSite is gonna stay in the lead for now. Is all crypto volatile? Now that you know like rewards are at stake, you're taking this seriously. All right. So not all crypto is volatile. As I just said, there are stable coins like USDC that have like a consistent value. What year did the Ethereum network switch to proof of stake? Nice. I feel like some of you were like whispering the wrong answers. Oh, none of these are correct. Well, that's on me because I have to manually select what's the right answer, and obviously I forgot here, so my bad. I lose points here. So dApps, as I said, they're decentralized applications, just like all the applications you're already familiar with, but with blockchain technology incorporated in various different ways. So how does that look like in practice? If we took like a random app, Web2 app like Skype, if you even remember Skype, I might be dating myself right now. Let's imagine like a Web3 version, a cool version of Skype that has a 3 instead of an E. So first of all, it wouldn't have a login with an email and a password. It would have a connect wallet button. And then if you have MetaMask like I do right here, it would ask you to sign that so you're connected to the dApp. That doesn't cost anything because you're not changing anything on the chain. You're kind of signing off that you do have access to the wallet and that you are accessing that application right now. The last slide showed a MetaMask pop-up screen, and what website was mentioned in the pop-up. It was very, very niche. The first obstacle is that if you don't have a MetaMask plugin in your browser or any other wallet plugin, you won't be able to connect to a decentralized app and you won't be able to interact with it. Then when you do, you have to understand like what this means and how to use it, which is another obstacle that you don't have in Web2 apps right now. You have the secret recovery phrase that you have to keep in mind. The next thing is, as I said, you have to pay gas fees all the time. So if you don't have enough funds, that will be an issue as well. And sometimes, depending on how well or how clean the smart contract has been written, you're gonna see clearly what you're about to sign, and sometimes it's just gonna be like a bunch of bytes and hex data, which is not ideal, but it's stuff like in the UI UX space in Web3 that we're working on. And also something that you're not used to in Web2 is that a transaction can fail and it can revert either because you don't have the right chain selected or because the chain is maybe too clogged and you have to do the transaction again. So all of this is to say that there's a significantly higher level of cognitive load happening on Web3 dApps, which is a major barrier to entry right now, stopping us from like more users adopting this tech. But it's something like that we're actively working on as an industry. And when I say cognitive load, I mean the amount of things you have to keep track of at once while like swapping a certain token for another token, because you have to keep track of the fees that you selected the right token. And the whole time you have to have in mind that you can't revert the transaction. Once you send those funds, they're sent. So it's a different level of responsibility. Now, going through the architecture of an app and a dApp, I like to use a metaphor of like food and pizza because I love food. So imagine you ordered pizza from like a restaurant. You're basically requesting a slice of pizza that gets to you, let's say, on a highway to your plate from this restaurant. An app's architecture is basically that, because you are requesting from a server a specific meal, a specific site, and through the internet, actually the highway, it gets to your plate, but actually your smartphone, for example. I see someone in the chat who's getting the gas fees, since the gas fee is paid whenever we make a transaction. To put it simply, the gas fees are collected by the members of the network that are giving their hardware and electricity to like pick all the blocks and keep malicious actors from doing bad things. So part of the fees that they're getting from all of the users using the chain. So it's a sustainable circle. So that's the basic architecture of an app, which I'm sure you're familiar with. Now, let's make things complicated, because if you look at like a typical app, you have the front end, you have the back end, you have the database. You technically can totally replace the database and the backend with the blockchain, because you can read data through smart contracts. Now, you don't have to, and usually that's not ideal because storing data on the blockchain is expensive. So it depends on what you're doing, but you can. You technically can just have like a front-end UI and read data from your smart contracts, change them there, and that's enough. Smart contracts you're familiar with now. But what I didn't tell you is that you can communicate directly with the blockchain if you're a node, if you're a member of the chain, if you're actively participating and giving your like hardware and electricity. If you're not, you can't directly communicate. But there are these so-called providers, and they give you infrastructure as a service. So they're like, I'm gonna give my own hardware and electricity to help the network survive. And through this JSON RPC, a remote procedure call, I'm gonna let you have access to the chain even though you're not contributing, but I'm gonna bill you some money. And so Alchemy and Infura, that's what they do. They give you access to the chain, but in return, they ask for something else. Now, you have a certain number of free pings that you can make through Infura, so you can play around with that, but after a certain point, they bill you like a monthly subscription. But so you can use them, and you don't have to like participate in keeping the network alive. And then once the user goes to your front end and reads data through the provider of the smart contracts, you need something that's called the signer. That's exactly MetaMask, what I have here. I need something that's going to let me sign transactions and actually interact with the chain. So you have all of this working together now. There's a decentralized way to store images and any other data that you like, and that's called IPFS, Interplanetary File System. You don't need to know this or remember this right now, but it's just cool to know, because maybe some of you are asking yourselves, okay, but if I'm storing my other files in a centralized way, then I'm still like vulnerable. So there is a way to like literally make everything decentralized. There is a question, do you have to? Because there's definitely a time and a place where it's meaningful, and time and a place when it's not. Sometimes the raw data you get from the chain is not really in the shape and form that you'd like, especially if you start working with like measurements of time. You're gonna want to show your users something like a month ago instead of like 16th of November 2024. That's where the graph comes in, and it basically scans and indexes all the data that you want on chain, just like Google scans and indexes specific pages. And then it lets you reformat everything in the way you want it. And then it serves it on the front end just how you wanted it. So that all sounds fine and dandy. But Ethereum has an issue that sometimes affects like everybody on the network and every dApp, and that is those are spikes of transaction fees. So sometimes if too many people are trying to execute transactions at the same time, transaction fees can get crazy. And there have been situations where like there's been an NFT sale of a collection called CryptoKitties. I know it sounds stupid, but people went so crazy for that sale that fees were like hundreds, maybe thousands of dollars. And that's a serious problem, because if you have a business that depends on regular transactions, and then the chain by itself is asking your users to pay high fees, is gonna affect you directly every time. So Ethereum is very decentralized and very secure, but it's not scalable. And I told you we can build like anything we want on top of Ethereum, and including that is actually another blockchain. So there are layer 1 and layer 2 blockchains. And we'll be talking more about that right now. So the layer 0 is actually the hardware and those miners and nodes that I spoke about. Layer 1 is Bitcoin, Ethereum, maybe you've heard of Solana, Near, and all these chains have different like benefits, different pros and cons. And so it depends really what you want to do when you're looking at like what chain to pick. And then layer 2 chains, they're made specifically for speed and scalability, so you don't have to tackle any of these like issues with high unpredictable fees. And layer 3, those are actually considered to be apps. So dApps, anything built on top of those are like consumer apps. So these are just some examples of the layer 0s that exist. Layer 1s, layer 2 like Polygon, Optimism, Scroll, and Arbitrum. And layer 3 are some apps like OpenSea, NFT Marketplace. Uniswap is a decentralized exchange where you can swap certain crypto for other ones. Hey.xyz is an on-chain social media network, let's say. Blank are all about scalability. So L1s, L2s, L3s, or L0s. Okay, so it's L2s. L1s are like the foundation. L0s are the nodes in the actual hardware, like keeping it up. And L2s are there to make things scalable and reliable. And L3s are applications. A dApp can fully replace its backend with a signer, IPFS, smart contracts, or a decentralized identity service. It was smart contracts. So the two of you should have gotten points. Okay, so zooming in on L2s. Basically, L2s are rollups. And what are rollups and why do they make a blockchain more scalable? And that like scalability issue is actually called the blockchain trilemma, because you can have a blockchain, you can imagine a triangle, and you can imagine scalability, security, and decentralization, and no blockchain has all three as of yet. So Ethereum is missing scalability, but it does have security and decentralization. Solana does have scalability, I'd say, but it definitely has had like a lot of downtime, so it's not considered secure, etc., etc. So what a rollup does, it takes like what would usually be one block, a second block, a third block. It rolls up many different blocks and all of their transactions inside them and puts them actually in one block. It basically imagine like it zips a bunch of things that will be stored separately into one, and then that is more efficient, and it makes fees more cheap, and it makes transactions faster. So if we zoom in a little bit more, it's basically a user pinging a layer 2, wanting to execute a transaction, it goes in a pool, just like we talked about for layer ones. But now this thing called the sequencer, it just takes over. It decides whether a transaction should be executed or not, and then it sends it to the layer one. Then the layer one communicates with the aggregator, and the aggregator batches up multiple transactions, and it sends it to the prover. And the prover's task is to make cryptographic proofs, ZK proofs, that actually this is all correct. And then it sends it back to the layer one, and then the smart contract on layer one needs to verify that these proofs are okay. And all of this is then like stacked together instead of being scanned separately. And that's still using the security of a layer one, but it's like zipping all of these together, making it faster and cheaper. So if you wanted to pick a chain for the dApp that you're building, it's not a simple choice, because as I said, like they have different transaction speeds. On top of the blockchain, you can't build, but on top of Ethereum, Solana, you can. Then you have to take into consideration like gas fees. Some chains or some L2s like Arbitrum One, they're general purpose, kind of like Ethereum, but it has lower fees than Ethereum. But then Arbitrum built like a separate chain called Nova that's built specifically to have like as low gas fees as possible. And that makes it great for like on-chain video games, social apps, like anything that will have like a bunch of transactions in short spans of time. So I made this like simplified chart so you can get like a bird's eye view of some of them. But in the case that none of these chains actually fit what you need, you can build your own chain. So now we're at that part. And all these layer twos, they've like published their own chain development kits. And some of them work on like the ZK rollup logic, and some of them work like with the optimistic rollup logic. The ZK rollup logic is everything I just talked about. And the optimistic one, the only difference is that it doesn't have the prover. So the optimistic ones are called optimistic because they don't even try to prove that the transactions were correct. Their logic is, I'm gonna wait for 7 days, and if anyone can prove that this set of transactions is incorrect, any of them, and if you don't, I'm gonna consider them correct. If you do, you're gonna get a reward, etc. And after a week, I think the data is gone. So if you don't react in those 7 days, the transactions will be accepted and they can be reverted. For example, Polygon made their own chain development kit. Polygon is an L2. And I didn't pick this randomly. Gateway is actually a core contributor on Polygon. And Gateway actually built the newest version of this chain development kit called Aragon. And it has like 40 times higher transaction per second, way faster sync time, a fraction of the storage footprint it used to have. And that's all really cool because it empowers everybody else to build their own chains the way they want to, that are cheap and scalable. So as I said, like these chain development kits are open source. I link them, I can send them to you guys later. And you can technically like go to the GitHub repo and attempt to start building your own chains. But it does get complicated real quick because you gotta set up the aggregators, the provers, the sequencers, a bunch of fancy words I'm saying right now. But also you gotta think about the block explorer. If you're building up a new chain, somebody has to take care of the block explorer, so you can actually see those transactions easily. You would have to also build a bridge. A bridge is what allows you to swap tokens between chains. So there's a lot that goes into it. And that's why what Gateway does is super cool, because Gateway handles that infrastructure for you with products it has built. So today it's going to be super useful when we use Presto, Gateway's product, for building your own chain. So you don't have to go through any of that like manually or by yourself. And we have a few more questions. Optimistic rollups don't have provers, aggregators, or sequencers. That's right, provers. So optimistic rollups are optimistic because they don't prove anything is correct. They just tell you you have 7 days to prove me wrong. I'm optimistically going to believe that nothing malicious just happened here. So that is compromising security, but that is because then you get scalability and cheaper transactions. So the concept of no blockchain having all three is called the blockchain trilemma. Dang, that would have counted if you added trilemma the gateway. It would be cool if they named the thing after us. So now we're at the practical part. Right now, if you don't even technically need MetaMask for this part, the way I organized it, but you would need it after. But let's go through this first, and then you can install MetaMask. So we're going to be writing a simple smart contract right now. I just have to go through the basics just so you get the gist of it, but you'll get a feel for it when we start writing it. So smart contracts are like very short pieces of code. They're supposed to be as short as possible because like any bytes of data makes everything more expensive when you deploy it. So what you can do, you can store like state variables, like numbers and strings or addresses. You can write functions, as you saw. They can be different types, and you can write events. So anytime a specific thing happened, there's an event triggered, and you can cache that on your front end. So what data types are there? The basic ones are like bool, which you already know of, true and false. Address is a specific type for wallet addresses or smart contract addresses. Each smart contract has its own address as well. You have a string, you already know about that. And you have uints and ints. And you're gonna see that uints and ints have this like 256 right next to it. Sometimes it's gonna be 8, sometimes it's gonna be 16. That's basically like scoping out the range that this number could be. So first of all, uint or int. The difference is uint makes these numbers only positive. So from 0 to whatever. Actually 2 times 10 to the power of 256. But ints can go to negative. So like how far can a uint go? And the exact opposite on the negative side, that's its scope. And why you would label a uint like 256 or maybe 16, because you want to make it as compact as possible. So your transactions are as cheap as possible and deploying the contract is as cheap as possible, because you have to be sparing with your resources. So if, for example, you wanted to put in like a data type that was supposed to represent your age, you would never put in uint 256 because you're never going to write up someone who's like 50,000 years old. So that's when you have to start thinking about optimizing. A string is a greeting, for example. You have a struct, which is basically an object. You can make like a custom object that has custom attributes like a name or age. And what else do we have here? And then you can like build out that struct. And you have a mapping. A mapping is super cool. because you can link like two separate types of data. For example, if I wanted to have like a list of all our names on one side and our age on the other side, and then I can specifically like say, I could input Mark and I could get his age on the other side, and it's a great shortcut for going through connected data. And you have arrays. So any type that you just saw can also be in an array format. So it's not just like the number 1, it's the numbers 1, 2, and 3. Visibility specifiers, they're public, private, internal, and external. You basically get the hang of them like after your first time using them, because like public variables or functions, you can call them by anyone from anywhere. Private ones, they can be only called within the contract itself, or the variable can only be seen within the contract itself. You have internal ones that you can only access, just like the private one, within the contract. So within this scope, from this line to this line, or inherited contracts, which is basically like when you make a baby contract within a contract, but like you don't even have to think about that right now. And external means that it can be only called outside the contract. I can give you these slides later. These are like cool notes to have everything in one place. And there are modifiers, so specific people can execute specific functions, which is very useful for security. So you can go to remix.ethereum.org, like Visual Studio Code for smart contracts online. It's super simple. You can go here on the left and you can say create new file. And you can, you can call it whatever, hello world .sol. If there's anyone that has already written smart contracts before, because I think 1 or 2 people have, I do have ready some more complicated versions. So the first thing that you do when you write a smart contract, you write this weird thing called SPDX license identifier, MIT. It's just a practice to write out the license right away, since when you deploy it, it will be on chain forever. So it's important to know if like there's authorship involved. This is like the most basic one that you always put, so you're okay. And then the first thing to define is what version of Solidity are we using. So when this does get deployed, before it gets deployed, we need to know how we should compile it. And it's different for different versions because this is like a language that's actively in development. So 0.8.26 is like the newest version, and this little cap here means like anything from this and above is okay. So consider it this version. And then when you're starting a contract, you literally write contract, open the brackets, and their whole contract will be here. When I do // it's a comment. It's not actually like registered as code, so I can write like whatever I want. Let's write our first variable. We're gonna be crazy. We're gonna say uint 256 because we don't care about being efficient with storage right now. And we're gonna make the variable public, and we're gonna call it count. I can call it whatever I want. I'm calling it count because this is a counter contract. So this is public, and the range is from 0 to 2 times 10 to the power of 256, which is a lot of zeros. And we can write our first function. We can call it get, open the brackets. And then we have to put in all the details like we put for the variable. So we want this to be a public function, so it can be called from anywhere within the contract or externally. Now I'm going to do something that's called returns, because I'm going to define exactly what type of value will this function be returning. And it's going to be uint256 as well. So it's like a basic function, like you're writing it in JavaScript, and Solidity is written based on JavaScript. You define like the visibility, and then if it's what you want to do, you can define like what type of value will it be returning, and that makes the whole function cheaper than if you didn't define this, because it knows like it's a more narrow scope. So we can just say return count. What's also something we can define here is we can add view. And when we write view here, that means that this whole function is not affecting the chain's state. So we're basically just reading this value here. We're not saying +1, -1. We're not dividing by anything, adding any variables. We're just reading it. So it's a view function. It's public, it can be called from anywhere, and it returns the same type of value that count is, because count can be only this type of value. So now we can make another function called increment. We also want it to be public. Since it's called increment, we're going to actually increment the count number. So I'm sure you're familiar with the plus equal sign, meaning that like every time this function is executed, count will be increased by 1. And to bring balance to the force, we're going to make a counter function that's going to do the opposite thing. So function decrement brackets public curly brackets, and we're going to say count minus equals 1. So by default, count is going to be 0, but if we wanted to, we can give it a default value. It's up to us and like what's our use case. So this is our first like hello world smart contract, pretty basic. Here you can see like other default stuff that's already been added. You can add files and folders, practice as much as you want. But this here is like the most important part on the far left. Okay, so here you have search, and below that you have the Solidity compiler. So based on the version that you wrote here, the compiler will be compiling based on that. Now I have auto compile turned on. If you don't, you should, because it makes life simpler. And if there's an error, that's where it will be telling you like, hey, something's wrong. So see, if I forgot to put brackets here, I'm gonna have like an exclamation point here. And it says, hey, I'm expecting you to start these brackets because it doesn't make sense to write counter and then uint. So then I'm gonna see, okay, it won't compile it because I'm missing this. So now it's okay. I can say compile manually. And yeah, so the next thing, the next section is called deploy and run transactions. So here it's going to give you like a mocked account that has 100 Ether, and you have like a bunch of them. And here is the contract that we've made, counter, within this file. If we made like another contract in the same file that we called counter, you would see both of them here. And you can deploy them separately because they're separate contracts. So it's recompiled, there's only that one. We want to deploy this. So I'm gonna say deploy. It's been executed successfully. You can see on the bottom you have this terminal. Just throw this down. Okay. And if you expand this view below deployed contracts, you can now see all the functions and the variables that we made through the contract. So like right away, it lets you interact with what you built, and it's like super convenient and simple to play around in this. So I can click on count because it's a public function. And now my screen, I'm pretty sure you can't see this. I'm trying to make it larger. See, if I totally zoom in, you can probably see here below count, it says 5. So, but if I put like 400
any number.
here,
Okay, you're gonna get 405.
yes, but not on this one because this is a already deployed contract that now like we can't change.
Huh?
But if I deployed another one, see this bottom one, it's gonna have 405. This is basically like it's making copies of the same thing, but they're different. Like as soon as you get the pizza out of the oven, it already has the ingredients it has. But when I do click increment and then I click count again, it's gonna be 406 because increment adds +1.
Actually, I think I'm doing something wrong because I'm still getting 0, even though I put like 405. Probably I'm doing something wrong.
Did you click deploy again?
Yeah, yeah.
And
That
then you
deploy.
opened the one that's on the bottom here?
Yeah, there is 2 of them, right? So
Yeah, the bottom one. Did everybody else do it?
Yes.
yeah, did you do?
Cool. Do you have any questions about this, or do you guys want to move on?
One question,
Uh-huh.
what is this balance? It's showing 0 ETH.
Where?
Above the increment, decrement buttons.
Ethereum.
Yeah, but it's 0.
Here?
In the, what do you call it, in the deployed contracts, if you click on it, you have the buttons like increment, decrement, count, get, and above them there is a balance.
I see. That's a
Yeah.
great question. That is the balance of the smart contract itself. So the smart contract has like a balance, just like a wallet has. If we were to write a function where we also to deploy the contract need to send some ETH, it would be like locked up in that contract just like you sent it to a person. So then people write smart contracts as their vaults. And that's basically how multi-sigs work. Multi-sigs are like multi-signature wallets that actually use smart contract logic to store their funds on a smart contract. So no one wallet can like move them. They need to agree with like multiple other people. The smart contract can have like it can have money just like your wallet or my wallet can. You can deploy this on any chain. You could like you can connect the compiler and everything with your MetaMask. And right now it's registering main network with the ID of 1, that's Ethereum. I can go to like the test net, which is the same exact copy of the existing chain, but it's used only for testing purposes. And then I can deploy it I could deploy it if I did have enough ETH in my account, but I don't, and that's okay. But what I wanted to tell you, like the custom chain won't really be here. So I'm gonna log out for a second. You have like on our website a bunch of different products, but Presto is the main one I want to show you right now because with it you can deploy your own custom blockchain and you don't have to go through any chains development kit or figure out by yourself what's best or how to do it. You can deploy this in a few clicks. So I'm just gonna sign in to my existing account. And you see here are already some deployed chains. If I wanted to, I could deploy another one. That's going to take a little bit though. So I'm just going to show you an existing one. But you can deploy different ones based on different things you need, just like we went through on that table, if you remember, with like all the stats. What's the transaction fee? What's the transaction speed? What are the gas fees like? Well, what's the general like purpose of the chain? What is usually being built there? Is it for DeFi? Is it for gaming? And then you would pick a specific thing. So also part of the rewards will be codes. For the first person, it will be like 2 months for free to build like any chain you want. For the second person, it will be a month of building any free chain you want, and the third person will get 2 weeks. Because this is vastly cheaper than doing it by yourself or trying to provide the infrastructure yourself, but it still does cost something. But we want you guys to play around, so we're gonna give you those codes. So as I said, I already have these chains deployed. I'm gonna show you Stavanger. So Stavanger uses ZK as we talked about, and if you don't have it, you can add it to your MetaMask right here. I already do. On the top left of your wallet, you have a list of like all the chains you've added. You can add new ones, and Stavanger is now here. So Stavanger is a public chain that has its own aggregator, sequencer, everything we talked about, its own RPC, so you can through that be in communication with the chain without like actually being a node and having to give your like infrastructure. You can see its chain ID. You can see like what's the gas token? It's actually POL. Let me just switch. POL, I have some. And the cool thing is, so Bridge comes already built. So you can easily swap tokens from here to another chain. If you're building this by yourself, you'd have to set that up by yourself. As I said, you would have to set up a block explorer by yourself, and there's already a faucet. And the faucet is just a place where you can paste your wallet address and get more free tokens, because this is a testnet. It's not an actual chain that has token, the native token that has value. So soon I'm gonna have like a little bit more POL tokens. So since we don't have a lot of time, I'm gonna show you what I've built instead of us building it together, and how I've deployed a smart contract on Stavanger. So there's this really cool tool called Hardhat. In Hardhat, I can show you. Hardhat is like a framework for building smart contracts and testing. So when you deploy a smart contract, you have to remember that there's no changing it after the fact, and everybody can see the code. So if you do have an exploit, it will be exploited for sure. It's just a matter of time. So by using Hardhat, it helps you write tests, and you can write bulletproof smart contracts. And it offers a lot of customization. Now I can send you guys later what are the few lines of code you would need to set up Hardhat, but it's super simple, because to just create a new Hardhat project, you will literally make a new folder, enter the folder, say yarn init, add dev Hardhat, npx Hardhat init, and you just set up the project that you want. And I'll show you kind of like how that looks like. Just 1 second. So you have a bunch of files here, but in the contracts folder, you have this lock contract that's like a template. You can or you don't have to use it. And it's just like everything we wrote in Remix. But it also has these folders for testing, the env, and what's important is that you set up the config. And in the config, you're gonna write like, what chain do I want to deploy this to? And if this would be like weird and you didn't know how to do it, especially if you're deploying on a custom chain, you can just go back to Presto and you can download this config file. So if we go back here, I already have this in my notes, so I'm just going to show you. You would just replace this with the file you downloaded, and you would get Stavanger with all the info that you would need to deploy this contract, and that's just the chain ID, the RPC URL, and in the env you need to add your private key, because that way through your wallet this contract is going to be deployed. And I'm going to stop myself from clicking the env and showing you my private key. I also added Sepolia, which is Ethereum's testnet, and you can add like however many chains here you want. It's just a matter of like what you're building. It would just have a different name, a different ID, etc. So when you're happy with these settings and you've written the contract that you want, you would go to Ignition modules, and here you write the logic for deploying it. So if it had some like predefined variables that you would have to fill out, this is where you do it. And if we look at the contract code, so in its constructor, it has unlock time as a thing you have to set. And unlock time, because this is a lock contract, means the time until your funds will be locked. Makes sense. So here it's already set that it will be January 1st, 2030 in the format that smart contracts can read. And this is like some amount of funds that's going to be locked. So all you have to do is create this module. You use this component from the Hardhat library. You call it whatever you want, and you just say, get parameter, and you make it this value that you already wanted. You make the locked amount the parameter that you already wanted, and you put in the value where you should. You see, when this goes through, if you looked at it through Remix, it wouldn't say balance 0, like the thing you asked about. It would say balance 0.000 something, because actually 1 ether would have like 18 of these zeros. 1, 2, 3, 4, 6. This would be 1 ether, but this is like a fraction of it. And yeah, I know this looks weird like this, like going through it so quickly, but if you just wrote it out one time, you would see it's kind of natural. So then if you're happy with this, if you wrote the smart contract you want, you set the chain you want, then you would go to your terminal and I'm in Hardhat test. Let me see if the command is here. Right. So I already deployed this. I can just do it again. The command is just something predefined. You would see in the library what it is. It's npx hardhat ignition deploy, and it's just the route where that ignition file is. And you say -- network, and you say which network. So I'm saying not Sepolia, but Stavanger. Cannot find module.env. Okay. Of course this is happening. As soon as the camera's on, of course this is happening. Let me just try this. Let me look at my package JSON. Okay. It's asking for the .env package because somewhere there I showed you it's looking for my private key, and to actually access the private key it needs the .env package to just be able to do that. So I'm pretty sure it's npm install .env. If not, I'm gonna Google it. Right, now it's added. It's right here. So all right. Confirm deploy to network Stavanger, Y or N, for like yes or no. I'm gonna say Y. And okay, it says the config version doesn't match 0.8.28, and this is 0.8.20. Okay, so if I went to the contract and I go back here, make it 20. I confirm, and now it's actually deploying it. Thank goodness. So this is actually going to take a little bit because executing a transaction takes a little bit, and then it should show us the address of that contract, and then we can track that on the Block Explorer. And if you deploy your own custom chain, it will look exactly like this to deploy a contract on it. And deploying a custom chain can be really cool because you can make a whole chain with gasless fees, so your users don't have to pay for that. If for some reason you need like KYC, like customer identification, you can make a chain that's only available to people who have went through KYC. So this is the address of our newly launched contract. And if we go to the block explorer of this chain, which we can find on the page, this is like Etherscan, just for Stavanger. See, if I paste this address, because it's unique, it shows me this contract. Its balance is 0 because I think it rounds down to 0, and we have this transaction from 2 minutes ago that is like the contract creation. So yeah, now we have like our own data on our own chain, and relatively easily with a library such as VM, you can show that data on your front end. So I'm not sure if I should keep going because of the time. I can answer your guys' question, or we can see who's the winner so we can give out their awards. And that's pretty much it.
Thank you so much, Akos. I know it was also like long for you, so we appreciate your time.
Oh, thank you. I mean, I love doing this, so there's nothing I'd rather be doing on this Monday. If they learn something new, then I'm happy.
Exactly. And what stood out to me is like I've been to like intro to Web3 sessions and stuff, but you basically explained it in such a comprehensive way and with like all the terms and like things that I like understand but I cannot explain. So like attending this at least first part for me was extremely insightful, and as a non-dev, obviously the second part was not for me, but I really enjoyed it.
I'm glad. I'm super glad if you found this useful as well. I mean, I really tried to make it like as accessible as possible to non-devs as well, because before I applied to like teach this to high schoolers as well, so I knew like I had to find like a simple, intuitive way, or it just wouldn't work. So I'm glad it works.
Awesome. And did you end up teaching this to high schoolers?
I did, yeah. I went like in
No.
2 weeks. I went to 8 cities and 8 high schools and taught about Ethereum, and it was super cool.
In Serbia?
In Serbia, yeah, we went on purpose. We went to like smaller cities that usually like don't have the opportunity as much as like the capital city does to listen in on free talks, especially not something so like seemingly abstract as the blockchain. Thank you guys for your time. I hope this was useful. I had fun, and yeah, see you at another workshop.